So we are going to talk about how to identify a system of linear equations, whether this system is consistent or inconsistent in this session. So first, let's recall what is the linear equation and what is the system of linear equation. As we all know, linear equation is the equation of first degree. The variable in the equation is raised to the power 1, not more. And linear equations, when represented on xy axis, it gives line, so it's linear. And the system of linear equations, system is a group of two or more linear equations must have the same variables. So let's take a look on these examples here and see whether they are system of linear equations or not. As we can see, we have here two equations of two variables x and y. All the variables are raised to the power 1, so they are linear equation. I have two equations in the system with two variables. Number of equations have to be the same as number of variables, and all the variables are raised to the power 1, so this is a system of linear equation. And here in emerald green, y minus 3x equals to 0, 5y plus x equals to 10. So I have a system consists of two equations of two variables x and y. All the variables are raised to the power 1, so this is another system of linear equation. When comparing the equations in a linear system, so the best way is to see how many solutions are there in common. So if there is any solution, or if there are any solutions in common, at least one solution, this system of linear equation is called then a consistent system. And if there is no solutions, there are no solutions in common in the system, so then the system is called inconsistent. By graphing, if we take these two lines that's representing different equations in a system of linear equation, if you can see here, these two lines that representing the equations in system of linear equation intersect in one point, which is xy. This point is the solution of the system. Then they are intersecting in one point, then there is a solution for this system. And I call this system consistent system of linear equation. But if I have this one in blue and assuming this one representing another equation, then the system here is called inconsistent system. This system here is inconsistent. So let's see some examples. Is this system consistent or not? Here is a system of linear equations: 3x plus 2y equals 18, x minus y equals minus 10. I need to represent these equations on the xy axis. So if there is of both lines intersect in one point at least, then the system will be consistent. If they don't, or if they are parallel, then the system is called inconsistent. So in order to represent this, I need 2 points for each line. So for this line, 3x plus 2y equals, if x equals to 0, then 2y equals 18, then y equals to 18 divided by 2, y equals 9. So I have a point 0 and 9. If y equals to 0, then 3x will be equals to 18, and then x will be 18 divided by 3 equals to 6. So I have a point here which is 6 and 0. If we represent it here on xy axis, I have 0, 9, and 6, 0. This is the line. This is a rough graph. And let's see the other one, the other equation here, which is x minus y equals minus 10. So when x equals 0, then minus y equals minus 10, then y equals to 10. So I have a 0 and 10 here. Okay, the point is here. And if y equals to 0, then x will be minus 10. So I have minus 10 here with 0, and this is the other point. Let's represent it on the xy axis and see. As you can see, obviously there is an intersection between the two lines that representing the equation. So this point here is the solution of the system, and this system is called a consistent system of linear equation. Let's take a look at another example. This one here, 2x plus 2y equals to 0, minus 2x minus 2y equals to 3. I need 2 points here. When x equals to 0, then y will be 5 over 2. So this point here is 0, 5 over 2, or 2.5. And when y equals to 0, then x will be 5 over 2 as well. So I have the point 5 over 2 and 0. I will take 2 points here on this line. When x equals to 0, then minus 2y will be 3 divided by minus 2y, both sides of the equation, then y will be minus 3 over 2. If y equals to 0, the x-intercept, then minus 2x equals to 0, to 3. Minus 2x equals to 3, then x equals minus 3 over 2 as well. I have minus 3 over 2 and 0. It will represent these 2 points. Okay, I have the first one here is 0, 2.5, which is roughly will be here, and the other one 2.50. So this is the line representing the equation. The other equation is minus 3 over 2 here, minus half, 1.5 with 0, and 0 minus 3.5. So this will represent the equation. As we can see here, both equations that representing this system here are parallel. What do I mean by parallel? They are not intersecting in any points, and they will not intersect in any points even if we extend the lines. So this system here is inconsistent system of linear equations. This example here, the same. I need 2 points on each equation. 2x plus 3y equals to 6. I will assume when x equals to 0, 3y will be 6, then y equals to 2. I have 0, 2. When y equals 0, then 2, 6 equals, when y equals to 0, 2x equals to 6, then 6 equals to 3. I have another point, 3 and 0. Let's represent the first 2 points or first line here. The first point is 0, 2 is here, and the other point is 3 and 0 here. This is roughly the line. Let's see the other equation here. I need a point. When x equals to 0, I will find the y-intercept, which is minus 5y. Minus 5y will be equals to 10, then y equals to minus 2. I have this point 0 and 2. This one here is 0 and 2. The other point, when y equals to 0, then x will be 10. So I have the point 10 and 0. This will be here 10 and 0, and I have 0 and 2. Let's represent this. Obviously, there is an intersection between 2 lines here in this point, and this point will be the solution of the system. So this point here of x and y is a solution of the system. So the system is consistent system of linear equation.